think I'm muted. Can you still hear me? Okay. I think earlier the YouTube audio was muted. Still cannot hear me? Okay. That's how about right now? Anyone? People on YouTube, can you hear me? Okay, yes, okay, that means out we are ready to go. So again, welcome to the Open Science workshop, and in the next couple of weeks, I'm going to teach some practical tools that you can practice open science. You can go to the link. I think I put the link in the chat and also in the YouTube here. I'm multitasking. So you can go to the URL. You can check out the agenda for this open science workshop. And open science is a movement that aims to make scientific research data more accessible to the general public. And it's going to cover, in this particular workshop, we're going to cover open data, open code, open result, open access funding, open result, and open publishing. The workshop series is sponsored by the University of Tennessee College of Arts and Sciences. And also we work together with the UTK library to give you this workshop. So the goal is to increase the awareness of open science. And you can also check out more information on the website. Some of the notable examples including openscience.gov and also the Jupyter. We're going to use Jupyter a lot throughout this workshop series. If you want to learn more, you can go to the link. You'll be able to find more information. So especially in the federal government, they have the Open Science Initiative, originally led by NASA. So NASA declared 2023 is the year of open science. You can scroll down to find more information. So a lot of government agencies pro open science, and there's kind of movement also in the scientific community trying to make research data more accessible, more reproducible. And so as an educator, I've been doing open source software development for I think over 10 years now, and I've done quite a lot, especially during the last couple of years after the pandemic. So in this workshop series, I'm going to teach you some of the practical tools that I'm using and some of the best practices that you can do open science. On the website, I put up some basic information here. You're welcome to go through the website. And here, a couple of sections here, open code. This is the first one we're going to cover today. And then next week, in 2 weeks, there will be open code. And then after pretty much every week, we're going to have one webinar. So the same website and also the YouTube live streaming, the same Zoom link. You should be able to join in the future. Also, we're going to have an in-person Open Science Symposium on April the 3rd. This one is in-person only. We're going to have two external speakers, Dr. Fernando Perez and also Dr. Tasha Snow for the in-person seminar here at the University of Tennessee. And on the left side, you can also find some of the courses that I have taught here at the university in the last couple of years. I have 3 courses. They're all open access. The first one is Introduction to GS Programming. So the entire course, you can check out the course content on the course website. If you're someone interested in learning Geospatial, this might be useful for you. And all the lecture materials, the entire YouTube series, they're all open access. If you're interested in getting a certificate, you can sign up here at the UTK website to get a certificate and also get feedback for your assignments. Similarly, I also have the other one, Geographic Software Design. So this is the course that I'm teaching this semester here in the Department of Geography. And it's still ongoing, but you're also welcome to follow through if you are interested in learning how to develop open source science packages and covering all the practical tools. So what we are going to cover today in this workshop is just basically to give you a brief introduction, especially if you're new to open science, new to open source software development. This might can help you get started. If you're already familiar, great. Maybe I can share some insights that maybe you may not know. And the other one is open spatial data management. So these are some of the open courses that I'm teaching. I have also written a book, published a book in 2023, Google Earth Engine and GMAP. Again, the book is open access. And in the last workshop, open publishing, I'm going to cover how you can write a book using open source tools and also make it openly accessible to the general public. So you don't need really fancy or contract to set it up. You can write a book and then make it reproducible using just Jupyter book, and then you can set it up. You can publish it online. It's all free. You don't need to pay anybody any money to write a book or to host a book. And this is what we cover at the end of this workshop series. I think in on April. Also, I'm writing potential another one, geodata science with LeafMap and also GeoAI. So welcome to check out the materials. They're all free, like I said. Lastly, there's the open source project that I have been developing. So this is a GitHub organization that I created that hosts most of my open source projects and data catalogs, so all the things geospatial open source. You're welcome to try out some of these things that I put up here. Welcome to adapt those for your teaching, for your research. And so maybe first I would like to ask, maybe let me know where are you joining from. I'd be happy to know where are you joining, and happy to see maybe in the future you also join in the future webinar series. And with that, let's get into the coding, okay? So today we are not going to do a lot of heavy coding, mostly just introducing the tools. But I would like to cover some of the things that how do you go from something that you develop on your local computer and make it accessible on the web so that anybody can access your stuff. Certainly, there are a lot of benefits of doing open science and open source because you can make your stuff more accessible to the public and more people are going to use your stuff. And you're going to have a lot of impact. So, but it takes time. It's not going to be like overnight that you're going to become a famous person in open source. It takes time to build up your audience, and also you need to spend time build up your project. But if you are new to this, today might be just to help you get started and how to create an account and then how to start sharing stuff. Before we get into detail, I'd like to quickly show you maybe just a simple example. If you go to oh, I forgot to share my screen, sorry. I've been talking a lot, but I forgot to share my screen here. Again, you can check out the link in the description. Earlier, I covered some of the materials we're going to cover here. In this workshop today, we're going to cover open code. And in the next couple of weeks, we're going to cover a couple other sections: open data, open access funding, open result, open publishing. And we're going to have an in-person a symposium at the University of Tennessee. We have external speakers, and these are some of the courses I earlier mentioned: Introduction to GIS Programming. So you can scroll down, you can find the course material and also the YouTube contents, all free and accessible. Geographic software design, this is the one that I'm teaching this semester. So if you're interested in developing open source packages, this might be useful for you. And open access book here, Google Engine, and also LeafMap, it's all open access. Check out the link. You'll be able to download the notebooks and then adapt to your research projects. And the last one is open source geospatial solutions. And so the first time I'm going to show you is maybe let's go to the Python packages here and click this GeoAI. So this is the new package that I've been spending time the last couple weeks, maybe the last week, trying to make it easier for people to use deep learning and AI for geospatial data. So one example I want to quickly show you, if you go to the website here, is that assume that you have some source code, or even new to open source software development, you want to make your stuff accessible to the general public or to people in your discipline. So this might be something useful that go from your notebook from your local computer to something on the web. So let's try out this one. If you go to the examples and then scroll down to find solar panel detection. So this is actually a notebook that I just created yesterday. And there's also a video tutorial on my YouTube channel. And you can just open the link here, open in Google Colab, right click, and then open a new tab. It will take you to the Google Colab. So this is allows you to run source code on the web without installing things on computer. So Google Colab is an environment for writing Python code, kind of similar to Google Docs for writing writing documents. And you can just click here runtime, and then change runtime type. From here, select T4 GPU, and then just click OK. You should be able to utilize the GPU because you want to do deep learning, and If you use CPU, it's going to be a bit slower. I already opened it up earlier, and let me quickly run through. This is not the focus today, but I'm just showing you some of the practical examples. Why do we want to do this, and what's the benefits of using doing open code, because other people can use your stuff easily on the web. So if I go to the very beginning here, right, and let me clear all the outputs quickly. So all you need to do is just to import the libraries and click this one. It's going to take you a couple seconds to install the package. And after that, you can just click run through that, import, and then download the sample data, get the metadata information, and then visualize the raster data set. All right, so this is a sample area imagery that's covering Davis, California, with a lot of solar panels. So assume this is some of the data that you have, and you want to detect solar panels, because you're going to see some of these images here have some of the solar, a lot of solar panels. And so all you need is just one line of code to initialize the model. So this is a deep learning model. Then just another line of code to extract the mask to turn it into a raster. So this is going to show you the progress. It is running right now, and it subdivided images into smaller tiles. After that, it's going to run the model, and then going to show you the result very quick. So this is something that you can do. Certainly, if you develop some algorithms and you want to make it accessible to other people, you should try to lower the barrier. So ideally, people just need a browser and then to access your products, your algorithm, then they can try it out themselves without having to set up things on their computer. And after that, you can visualize the mask. I think right now the raster mask doesn't work very well here, but you can just quickly run this line to convert them to vector. And now we have this vector dataset overlay on top of the original imagery. And this is interactive, so you can see the polygon here very nicely. All the building, the solar panels have been detected, and you have this one readily available as a vector data set. So you can zoom in, you can zoom out. You might notice there are some artifacts in here. For example, these are not solar panels. AI is not perfect. It's going to sometimes give you some false positive results. So you do need to be careful about that. You need to do some evaluation. But in this case, we can simply just calculate some geometry properties here. And because they want super long, elongated, we can just remove that based on the size or based on some other geometry property. So initially, we have 44 solar panels. And after we visualize using the elongation, so you can see it here, this one is yellow color, means it's the very long elongated solar panels. That one is not right. And then we can just run some filtering to remove those that are super long or that are very tiny objects. So now we are down from 44 to 42. Lastly, let's just visualize the result. So now you can see we are visualizing the solar panels using some color. So the yellow color represents large solar panels. For smaller one is basically the blue one represents smaller solar panels. And lastly, this should be what the final outcome looks like. So zoom in to see here. These are all the nicely solar panels that have been converted nicely from the raster imagery. They kind of have pixelated edges. Now we have these nice looking vector polygons. And look at this. So literally, if you run this one all at once, it takes you less than 1 minute. You get the solar panel, and then you can do this one at larger scale. And there are a lot of open access data, high resolution imagery, especially in the US. So you can apply this one to detect, for example, the increase of solar panels in a particular area. You can also get the histogram distribution of solar panels in a particular area. You can also get, for example, summary statistics. How many solar panels? What's the standard deviation? What's the mean? So roughly in this area, the median is 25 square meters in terms of the solar panels. You can also get the total size, 1,229 meters solar panels. Lastly, you can just save this one to a vector data set. Then you can open it in desktop.js or other stuff. So this is just a quick rundown of the example that I just created yesterday. Not particularly for this workshop, but I'm just showing you now this is the way that you can make your data product, your algorithm more accessible to the general public, because anyone can just open that in a browser. They can try things out themselves, and it's super powerful. All right, so this is just the example. So let me disconnect and remove this one. And My light's off. Let me move around. Okay. All right. So next, let's get into today's workshop. Open the code. So how do you make your source code open, public accessible to other people? And so we're going to use a couple of 3 tools that I use daily. And if you scroll down, you can find more content in here. So we're going to cover how to use Git and GitHub. You might be already familiar with this. So the last one is UV. So UV is the new Python package manager that can use to do create virtual environment, allow you to manage different Python environment. We will not get into details about each individual one, just to give you a quick overview why we're using this, how to use this, how to get started, and how to put your source code quickly on GitHub. So Git is basically a version control system, allows you to write source code and then have different version. GitHub allows you to host source code. So you can think about Git is something you can use to write something, kind of like Google Docs or Microsoft Office used to write documents. And GitHub basically is a platform that allows you to share your stuff. Think about that, you can upload some documents and people can contribute to your book, to any document that you're writing. If you're into Python programming, then UV might be useful. This is a new package manager I think just launched last year, and it has become very popular because it's super fast. So today I'm going to show you how to install it. Again, if you're interested in learning more, you're welcome to check out the open access course that I'm teaching right now this semester, Geographic Software Design. If you scroll down to the bottom here, I have the entire semester covering all the tools that you can use to do open source software development. So today will be just a brief introduction to that. And so let's get started. So right now I'm using a Linux computer, and I guess many of you are using Windows. So I'm going to show you like using Windows. Then I switch back to Linux. All right. So I'm going to go back to my virtual computer here. Okay. So right now I'm on Windows now. So you can scroll down to get the link. And you need to install 3 pieces of software, the Git and GitHub and also UV. So here, under the prerequisite, just click here, download Git. All right, and open this one in a new tab. Take you to this website. So click here, download this one. Depending on the operating system, so you can download it for Windows, Mac, or Linux. So click this one, download for Windows. You can select depends on your operating system. So I'm going to select 64-bit here for Windows. Save the setup.exe to your computer. Okay, and then you can just go to your downloads directory, and I'm going to double click. Okay, so now we can start installing the package. So just you can pretty much just follow the default settings. Oh, I already have that, so I already installed it before, so it's removing my existing one. But if you're new to this, just click all those buttons, just next. Use all the default settings, it should be fine. Then you should have Git installed on your computer. So this is useful if you need to push source code to GitHub. So if you want to share your source code with someone else, it's a tool that's widely used in the industry and also in the open source software development. So if you are doing open code, highly recommend that you use Git. You can certainly use the GitHub interface. You don't really need to use this one, but GitHub the interface is limited in terms of functionality. So, all right, once it's done, just click finish. Then you are ready. So Git is ready. So the next piece of software is VS Code. So again, right click, open a new tab, take you to the VS Code website, and click this one, download for Windows. Okay, and save this one. After a couple seconds, you should have that one ready. Oh, by the way, so if you have any questions, feel free to drop that in the chat. At the end of this workshop, I will be able to help answer the questions. On people on YouTube, you're also welcome to put it in the chat. I will go through the questions later. Okay, the installation is finished. Now you can just double click to install it. Accept all the agreements. Click next. you can check some of these boxes. So I recommend check the box add open with code. Open with code to on your basically context menu. So when you right click a folder, you can open it in VS Code. So kind of like a shortcut. And click next, install. And you stay a couple seconds, then you should be able to do that. So VS Code is basically IDE, integrated development environment that allows you to write Python code. It's not necessarily doing programming. You can use it to write text, markdown, anything like it's just a lightweight editor that it's very powerful because it has a lot of extensions that people can build it up and then add a lot of additional functionalities. Okay, once it's finished installation, then you can click finish, or you can launch it if you want to. So finish, and it's gonna open up. So if it's the first time, you're gonna see the welcome menu like this. So we have the VS Code. Last one is to sign up for a GitHub account. So if you go to here and scroll down, maybe let's install the UV first, okay? So go to this, click the UV, let's install, finish all the software installation, right click, and so from here, you should be able to find the installation instruction for installing UV. So it depends on your operating system. If I'm on Mac or Linux, you can just copy this command line to install it. On Windows, you can use this one. So here on the right, there's a copy button here. So this is just basically a PowerShell script that allows you to install using a command line. So there's no setup installation file for you to install. Click this one, and then open your terminal on your computer. So this is just the Windows PowerShell, and just right click. It should paste the script, and then just paste and hit enter. It should be able to install this one. It's super quick. After that, oops. Okay, it's all done. So recommend just close this terminal and then reopen it. Now you can try it out. You can just type UV lowercase. You see? So it has been installed successfully. It's a very tiny program, but it's very powerful. So if you need to install Python environment, this is the recommended way to set things up. All right, so we have 3 pieces of software set up. Now we are ready to do some real coding, like how to share your code. So we're going to use GitHub. I'm going to skip this section, installing Git and basic Git commands, because later we can just use VS Code to do share your code to GitHub. So you don't necessarily have to use Git. You don't need to use command line if you don't want to. So what you need is a GitHub account. So scroll down to section 3 here, introduction to GitHub, and then copy, click this link. If you already have a GitHub account, great. If not, now is the time to sign up for a GitHub account. So upper right corner here, there should be, if you open it up, it should be a sign up link. So let me copy the URL, open in incognito mode here. All right, so upper right corner here, you should be able to see this sign up button, and then just click sign up, give an email, and then set up a password and also the username. Then you should be ready to go. You might need to set up two-factor authentications. So take your time, set up an account, then we can start creating a repository, and then you can start sharing source code to GitHub to the general public. And so, oh, by the way, so one more steps here. You need to set up your email and also username. So go to this basic Git command here, because later when you try to synchronize your source code to GitHub, you need to GitHub need to know who is committing the source code. So you need to know your username. So this username is the GitHub username that you just signed up, and also the email address is the one that you use for GitHub. So make sure that they are the same. So what I recommend, just copy this one line, and then you can open maybe a notepad on your computer. So make changes, for example here, Control V, and then from here, change this one to your real name. So I'm going to copy here, all right, and enter your real name. So this is the first one. Then just copy this one line of code, open your terminal, okay, So from here, just paste the command line here and just hit enter. You will be able to set your username. The other one is your email address. So again, copy the second line here, Control C, and paste it to the notepad. Right, and change this one to your real email address. Okay, so once you're done, then you can just copy this one. So let me change my email here. Control C, and then right click, hit enter. You're ready to go. So now your Git knows who you are, what's your email address. So later when we synchronize with GitHub, it knows it's coming from you. So this pretty much the command line that we need to use. After that, we can just use VS Code. There's no command line anymore. Super convenient. All right. So let me close this one. So after that, open VS Code. Let me full screen here. On the left side, lower left corner, you should see the account icon. And just click this one. Select backup and sync settings. So this allows us to connect to GitHub. So in that way, we can pull source code from GitHub to our local computer, or you can also synchronize source code from your local computer to GitHub. So just click this one, and then upper right corner here, there should be a sign in button. So just click sign in. Select sign in with GitHub. I recommend just use this option. It's easier. So sign in with GitHub. And then you can open just a new tab on your computer always. From here, click continue. All right. And now just click open VS Code. So conflict, I can accept remote settings. So I'm going to basically override my local settings. If you're new, it won't show you anything. But the nice thing about the backup and synchronizer setting is if you have VS Code set up on multiple computers, this will allow you to synchronize between different computers. So you can download all the settings so you don't have to reinstall them every time. On the right here, if you click this one, extension, right now you see this kind of the clock here is basically installing all the extensions that you have under your account. If you're new, probably you don't really have much yet. For me, I already have a lot of extensions installed. If you want to install extensions on the open source, the website here, I also show you some of the extensions that you can utilize. So if you go to the VS Code section number 4 here, section number 4, and you can find some of the important extensions. So if you're using Python programming, you definitely want to install the Python extension, Jupyter Notebook, and also maybe GitHub Copilot. So basically, it's just AI to help you writing codes more easily with a lot of auto completion. I've been using this for a couple of years. It's going to increase your productivity a lot. There's also some extension packs here if you want to install, so you can click the link. And let me quickly go back to VS Code here just to show you. All right, so you can just search, for example, Python. All right, and if you haven't installed it before, there should be a button here, so you like the install button, or upper left corner here, you also should see the installation button. After that, just click one click and you'll be able to install all the extension. Or you can just do the data science, just search data science. They have the data science extension pack, ACIENC. Okay, Python data science. So the first one, you can also install this one. It will install multiple extensions together, so including the Python, VS Code, and Jupyter Notebook. So these are some of the basically the shortcut they can install multiple extensions together. So whichever you prefer, install these extensions, then we can start doing coding. Okay, so and then I'm going to close all of this. So hopefully by now you have all the software set up properly, and we are ready to create some GitHub repositories. Then you can start sharing your source code and synchronize with your local computer. I'm going to switch to my Linux computer now. So I'm back here. And so let me show you how to do that. I'm going to go to the GitHub homepage here. So upper right corner, there should be a button here. So I'm going to create a new repository, allow us to have some text, documents, data. So this is essentially where you share your source code to the general public. So click this button, create new repository, upper right corner here, create this new repository, and you can enter some settings. So for here, you need to change, for example, owner. If you just yourself, you should just automatically populate it. And for this one, you can give a repository name. So I can maybe just say open code demo. So try to give a name that's useful and descriptive. Also, you can give a detailed description here. Sample repo for the open science workshop. Okay. You can choose to whether to make this one open or public, or you can make it private. So it's up to you. So in this case, I'm just going to use the public, and then check this box, add a README file. So README file basically is just the documentation telling people what your repo is about. It's called Markdown. So we're going to briefly introduce Markdown later. So add a README file here, and all right, get there's a recording. What's the proof? You have reached the recording limit you're playing. Don't worry. It's the recording also available on YouTube, so it's live streaming, so you will be able to see the recordings later. I'm not quite sure about what's going on with Zoom. This is the first time I'm using it to do the streaming simultaneously. Oh, that's Opta. Never mind. That one is just the AI summary, so it doesn't really matter. As long as the video is there, we should be fine. Thanks for letting me know. All right. So next, add git ignore. So this one can be useful if we are doing, excuse me, using a particular programming language. So for today, we're gonna just type Python. The .git ignore basically means sometimes if you have some file that generated temporary file that you don't want to synchronize to GitHub, or maybe some sensitive information, you can add a .git ignore. So we're gonna just type Python and then select the one. Also, you can choose the license. So the license basically allows tells how people can use your stuff. There are a lot of licenses here. For me, I will just select this MIT license. Means that you are free to use my source code to whatever you want. It can also be for commercial purposes. Basically, do whatever you want. But if the source code burn down your house, don't shoot me. Okay. So it's basically do whatever you want. I'm not reliable for any damage that you might cause to your property, to your personal stuff. Okay. So if you're interested in other stuff, then you can try out. If you're new, you are not going to create something that's going to be used by so many people yet. So this is just a very permissive license that many people use. Then just click this create repository, and that's it. So now we have a repository. So if you're new to GitHub, congratulations. This is your first GitHub repository, and you don't really have to use any command line or use any coding if you don't want to. You can just use this one as a open data repository that allows you to share anything with the general public. So next, I'm going to show you how you can actually add some new stuff. If you click this button here, upper right, there's an add file button, and it's going to allow you to upload files to your repository. So you can solely just use the interface to add new stuff. So click this upload file button. Okay. Then you can drag any file to your to the repo, or you can click this one, choose your files to open a dialog box, and you can select files from your computer and then just upload it. So for me, I can show you, for example, I'm going back to the solar panel example that I showed you at the beginning, right? Upper right corner here, there's a button. You can click this button to download this one to your computer. So, oops, and you can give a file name. So solar panel. You can use any other notebook that you have. So solar panel detection. Okay, hit enter. Now we have this file on our computer, and after that, I can come back to my downloads directory. So all you need to just drag and drop this one, and that's it. So here you can give a commit message. So the commit message basically allows you to give a description about what this one is about. So you're going to do a lot of operations, and Git basically is composed a lot of Git history, because when multiple people are working on the same project, you need to tell them what changes you made. So try to give a descriptive information here. I'm going to say add solar panel detection notebook example. Okay, and you can give a more detailed one if you want to. I'm going to just click this one, commit message. All right, you see, now we have this notebook. It's enough, right? So if you are just a beginner, you have developed something, you want to share with other people, and this is the easiest way. It can be a Jupyter notebook, it can be a Python script, it can be any file you want. Certainly, GitHub is mostly for source code. If you have like MKV, music, videos, last one is not very suitable. I will show you maybe in another workshop when we do open data. I will show you like some of the common platforms that you can use to host data unlimited for free, and also make it accessible to the general public. You can access the data programmatically. We don't have time to get into the details today, but I just want to quickly show you this is what you can do. And you can also upload Python script. For example, earlier in Google Colab, I already have the file. I can download this one as a Python script instead of a Jupyter notebook. So similarly, you can save this one to your computer here, solar panel. Detection, hit save. Okay, so similarly, I can go back to the GitHub repo here, click add file, upload file again, and choose the file. Okay, so you can select multiple files on a computer if needed. I already uploaded the notebook, so now I just want the Jupyter notebook. So just click open, and similarly, add solar panel Python script. Okay, click commit messages, and that's it. So very simple and easy. We don't really need to use any command line. It's just use the interface. Nice thing about this is they allow you to upload data, but if you need to make changes, it becomes a little bit convenient, especially if you're doing Jupyter notebook. It's not very suitable for making changes. If you're trying to edit Python script, it's probably okay. So you can click this one, and then upper right corner here, there's an edit button here. So you can actually edit this one. So click the edit button, then you can make changes. For example, you can remove something, you can add some new stuff, or I can just remove some text from here, right? Once you're done, upper right corner here, again, commit messages, commit changes, same thing, click this button. Then you can improve the description, or you can just use the default one, just click commit changes and go back. So upper right corner here, there's a commit. So this one shows you what kind of changes have you made. You're going to see some red crosses here because I have the pre-commit. We don't have time to cover this one, but you can ignore that. You don't see this one yet on your local, on your repository. So once you have this, now you can see we have all the things set it up. By the way, if you have any notebook on your computer, right? So assume this is your GitHub repository. You have developed some source code and you want to share with other people so that other people can run your notebook examples. If you click this notebook, it's going to open up in Google Colab. Right now, we haven't really updated the URL here yet. So if you right click, open this one, it actually opened the notebook from my repository, from the GeoAI repository. So if you see the URL, this is not the link from your local computer. I'll show you how to update it. So for now, assume that you already have a notebook uploaded on GitHub. So how do you quickly open this one in Google Colab so that you can test your notebook in the computational environment? I recommend just go to the upper right corner here and you will see github.com. So all you need to do is just to add GitHub to Colab. So just add, after GitHub, add to Colab, and then everything else remain the same. Then just hit enter. It will open this one in Google Colab. So now this one is coming from a repository. So this is the easiest way, not just for opening notebook on your own GitHub repository. You can also open any notebook on GitHub. So if you are browsing GitHub, you find some notebook example that are quite interesting. You don't want to download to a computer. You just want to try it out on Google Colab. So just github.com change to github to colab.com. Then you open it up. Okay, so this will be the URL, and assume right now, okay, this is good enough. I want to actually update it, the URL, so that it becomes your example, become your own URL. Then we can do this. So go to the open your VS Code. Okay, so I'm going to maybe close the folder. So what you can do here is to clone the repository to your computer. So when you open VS Code, if this is the first time, you should see this one, clone Git repository. So allows you to clone the source code. So basically make a copy to your computer. So just click this one, and then at the top here, click this clone from GitHub. And by default, it's going to show you all the repository for your computer. And this is the one that we just created, open code demo. You can also do a search, for example, open code demo, right? So select whichever new repository that you just created, then click, and it's gonna ask you to save this one to your computer. So what you can do, you can select whatever directory you want. I'm going to go to my downloads directory, then click OK. Open, and that's it. So now we have this repository cloned to a local computer, and this is where you can start making changes. So if you open this notebook, assume that you have already installed the Python extension and also the Jupyter notebook extension. So you can just double click the IPYNB. It should open this one on your computer, on the VS Code. So this is notebook that assumed is you are developing, you want to make it share with other people. But right now we need to update this open in Colab base, right? So just double click, and so we need to replace this URL because this one is linking to the GeoAI repository. It's not your repository. So again, go to your repository, and then from here you can simply copy this one, or you can just add to Colab. Okay, again, I'm going to zoom here so they can see clearly. Just add to Colab to this one. You can copy this URL, or you can hit enter to redirect. Oops, to Colab. I think there's a typo here. COLAB. Okay, hit enter. It's not working. Let me do it one more time. To Colab, hit enter. Okay, so this will be the URL pointing to your repository because you're using my username here and also the repository name. After that, just copy the URL, come back to VS Code. Okay, so here, just replace this URL. Okay, and then Control S to save this file, and you can just Shift Enter to execute this code block. Now, if you click, excuse me, if you click this open in Colab base, and take a look, now it's opening from your repository, your own repository, and it's good to go. So the last step will be just to commit changes to your repository. On the upper left corner here, you should see this tree icon. So this is GitHub source code, and similar to what we did earlier on the GitHub website, allows you to upload the file and then write a commit message. For us here, we are going to just simply write a message. For example, update Colab link. Okay. On your keyboard, you can press Control Enter. After that, you should see this one, sync changes. Just click it, and it's done. So after that, I can go back to the GitHub repository. go to the home repository, you will see this is the one that we just updated, right? And you can, on the right here, you can see the number of commits. You're able to see all the changes. So this is how you can synchronize your source code from a local computer to GitHub. Again, you can click this one to open a notebook. Now, if you click this open in Colab page, it's open this one directly on Google Colab. So this is how easy it is to create a new repository, upload some files, and clone to your local computer. Then you can synchronize between your computer and GitHub. Of course, there are some other a lot more information about how to use Git. We don't have time to go into every technical details, but you're welcome to go through the documentation. You can use command line, you can use the VS Code interface. And we have roughly 10 minutes. So lastly, I'm going to introduce a UV. Earlier, we already installed UV because if you download some source code, you might want to run some source code on your local computer. You don't want to rely on Google Colab all the time because it's just temporary environment. Once you close, for example, here, once you close it, it's gone. So if you install any packages, you'll be gone like after you closed it, maybe for a couple minutes. If you open it immediately, it might still be there. So if you're really into open source software development, you certainly want to create some Python environment on your computer. So we're going to use UV here and scroll down to here, introduction to UV. So this section gives you some simple commands how you can create an environment, and then you can test those run the packages on a local computer. So let me show you. I'm going to quickly maybe go to my, for example, my download project here, and I can create a new directory, maybe called project, okay? Then open your terminal. So here, I'm going to create a new Python environment. You can look at the scripts in here, so you can follow it step by step. I'm going to just show you, maybe show here so they can see my screen a little bit bigger. So UV, just type UV. Make sure that it works properly. This is the one that we installed earlier, right? So once you have UV, then we can start creating environment. Just type UV venv, and it's creating a new environment. By default, this is using Python 3.12.6, but you can change the Python version if you want to, like UV venv. If you want Python 3.11 or Python 3.12 or 13, this is where you can specify the Python version. So I'm going to use 3.12. And you see here, it's super quick, it's super fast. It's like takes you seconds. And once you have the environment, it's activated automatically. So if you go to your downloads directory, right now on your home direct in the project directory here, it doesn't show you because it's a hidden directory. So if you're on Windows computer, you might need to show the hidden directory. On Mac or Linux, it's actually command period. If you press command period, it will show you this hidden directory. So this is the virtual environment. It's an isolated Python environment that allows you to install all kind of packages. You can delete it if once you're done. So it's super nice rather than trying to mess up with your system Python installation. Okay, so next, let's install some packages, right? So earlier I showed you how to use the GeoAI package. You can actually install things from here. So just type UV pip install, and then Jupyter Lab. This one allows us to open the Jupyter notebook, and then just type GeoAI dash Py. So this is the Python package that we use to run the Jupyter, the solar panel examples. Then just hit enter, and look at this. It's going to download all the packages. So it depends on your internet speed. This might take a couple minutes. I have fast internet speed, so it's super fast. It's installing all the dependencies, including all those GPU CUDA dependencies. So look at this. So this is pretty big. All the NVIDIA, because I have a NVIDIA GPU on my computer. So you will be able to automatically install all the dependencies. For those of you who are already use Python, if you're using Mamba, Conda, try out UV. It's so much faster when it's resolving all the dependencies. So right now, literally, we are installing all the dependencies. And later, you can create a new environment, and it's super quick. It takes you less than 1 second to create a new environment. You can also switch to different Python versions. So see here, just maybe I would say 20 seconds, you have the environment ready to go. And now you can start using that to execute your environment. So I'm going to maybe close this one. Okay, so I'm going to go back to the project here. This is the one that I have. Okay, I'm going to move maybe this Jupyter Notebook example within the Python directory. So after that, you can just right click, open in VS Code. If on Windows, just open VS Code and then just open the directory. So here, now we have this notebook on our local computer. So just click that. It's going to open. Then upper right corner here, there should be a button allow you to select a kernel. So click select kernel and then Python environment. It should be able to detect your Python environment. So if you see .venv, so this is the one that we created using UV. Okay, just click this one and then you're ready to go. So we have the environment set up and we can try it out. For example here, just you don't need to install this again. We already installed it. Just click import UV, see if it works. This one sometimes can be a little bit tricky, depends on the operating system. Sometimes some of the dependencies might not install properly on some computer. It's perfectly normal. You might need to do some debugging. If you run into any issues, you're welcome to report an issue on the GeoAI Python repository. So if it's the first time that you are installing or running notebook, sometimes you might run into issues. So you see, it's importing the package. Everything runs properly. Now I'm ready to go. So we can download the sample data. We can print out the sample basic data information, and I can visualize the data on my local computer. So this is exactly what I showed you at the very beginning of the workshop, and I can initialize the model. So it's going to download the solar panel pre-trained model, and now we can just run the inferencing. So this one is using GPU, and right now it's using GPU, so you might see my audio. My video is a little bit laggy probably because I'm running a lot of things simultaneously. But once it's done with the inferencing, the video should be back to normal. But I'm just showing you this is how you can go from creating a repository, getting some examples, and then running on your local computer. Set up the environment, test things out. Almost done. Okay, so now it's done. We can visualize the mass. Just what I showed you earlier. So you have the raster imagery. You can see it's like all rocky edges. Then after that, just vectorize the mass, add the geometry properties, and then doing the filtering. Here, run step by step. This should be super fast. And the last step, the last step is to visualize the vector data, and that's it. So literally just minutes, so you can get your Python environments up and running, and try it out yourself. Set it up. If you have run into any issues, you can go to the GeoAI GitHub repository and open an issue here. Create an issue if you want to. Okay, so I think that we are about time. We have 2 minutes. So this is what I want to show you. It's a very brief introduction to open code. Like how do you share your source code with somebody else, or how do you get the source code for somebody else and then test on a local computer. There are a lot more. So if you're interested in learning more, welcome to check out the open access course, especially the geographic software design. This is actually not just for geospatial. It covers a lot of practical tools that I'm using daily to do open source software development, and UV, Mamba, a lot of other things. So try it out. And that's all I want to show you. We have a couple minutes for Q&A. So if you have any questions, feel free to drop in the chat. Happy to answer your questions. And let me open the chat here. So right now I'm showing you some of the chat history from YouTube. So for people on Zoom, you are welcome to unmute yourself. If you have any question you want to ask, I can allow you to start your video and maybe also unmute yourself. And feel free to ask questions if you have any questions, if you have any comments, if you have any feedback. This is just the first workshop. I'm going to cover how to share data publicly, how to make a result more reproducible, more accessible, and how to write computational documents, or even how to write a book using open source packages. So stay tuned for future webinar series. Anyone, any questions?
Yeah, I can ask a question.
Yes, go ahead.
Yeah, so my question is about how big the imagery we can use for detecting of the solar panels.
It can be very big. So under the hood is subdividing your images into smaller tiles. So it's like 400 by 400 or 512 by 512. If you go back to the example earlier here, let me show you the process. It can deal with large data sets. So if you look at this one, detect generated mask. And I'm going to show you this is, for example, 6,000, more than 6,000 by 3,000. And it's subdivided into 400 pixels by 400 pixels. So you can actually, it should be able to deal with gigabytes imagery. It doesn't feed all the data into the GPU directly. It's taking all the smaller pieces, and then this one we're using a base size of 4. So basically, if you are feeding 4 small images into the model and then generate the result, and it's putting in the memory, and then in the end, you're going to merge them all together. So welcome to try it out. I have not tested in a huge images yet, but I did test it in USDA name imagery. There's like the original image tile that's I think 300 to 400 megabyte. It works just fine. So, and I only have a small GPU like 6 gigabyte. You can run those images without any problem. So you should be able to write gigabyte images without any problem. And certainly there might be some room for improvement. I'll look into that so I can showcase some more tutorial how to apply it on a large data set. But at least for now, I think it should work fine for a couple hundred megabyte. And if you have like 100 gigabyte, then might be a different issue. I have not tested yet. You are welcome to also check out the YouTube tutorial here. I think this is number 10. So I've created over 10 tutorial how you can use GeoAI, the package, to do all kind of machine learning and deep learning. Okay, any other questions? I have too many chat, so I need to go through that. I'm going to look at the Zoom chat first. I'm not sure if you can see me here. If you are on Zoom, you're welcome to unmute yourself to ask questions, or you have any feedback. Feel free to do so. Welcome everyone. Thanks for joining. Can we use thermal images for solar panel segmentation? Yes, but right now the model is using RGB, so you probably need to basically generate like RGB from the thermal. If for the thermal, you probably see some like very high temperature from those solar panels. I haven't tested it yet, and probably there's no pre-trained models specifically for that. So you might need to fine-tune the model. And stay tuned for more tutorials. I'm going to show how you can, for example, use your custom imagery to train your model yourself, and then you can use that to do detection rather than using the pre-trained model. What's the pros of using VS Code instead of notebooks, Colab, and Jupyter? Good question. I think I use VS Code every day. Jupyter Notebook, Colab, as I mentioned earlier, is good for sharing things to other people, but it's temporary. So once you close it, it's gone. You need to reinstall all the packages all the time. It's not very convenient. Jupyter is good, but it doesn't have a lot of functionality for using a lot of extensions, AI. Maybe give you an analogy. Jupyter Notebook would be like Windows Notepad, right? And VS Code would be like Microsoft Office, like Microsoft Word document. because there are lots of lot of functionality they integrated and makes it so much more powerful. But it's still a lightweight package, so VS Code it's probably the most popular IDE. And there's also another version called PyCharm if you use like other Python packages for software development. But VS Code is the open source one that's most popular. And what is the maximum area that the system can detect? The number of areas it can do the community level. Like I said, it doesn't matter. You can fit in a huge imagery, maybe a couple gigabyte. The model should be able to do that. So it doesn't matter how big it is, because it's not feeding the entire imagery into the model. It's subdividing into smaller tiles and then just feeding those image pages into the model. And but it's still keeping some of the metadata intermediate result in the memory. So at the end, because you need to merge the result back as a single raster of vector data, so it might be a little bit slow. I'm not quite sure, but I've tested the original NAP imagery. It has no problem. So try it out. Okay, so I think I've answered all the questions on Zoom. So next, let me take a look at the questions on YouTube. From a question from Valley. Let me move this one here, see if we can see it. I have a question. The method automatically finding solar panels does not interfere with the appearance of greenhouses. Maybe, I'm not quite sure. So in the area that I tested, it works fine, but certainly there will be some confusion, and you do need to verify that. Again, AI, don't trust everything AI that gives to you. Sometimes it can be a lot of false positive, and also it tends to the pre-trained model sometimes tends to confuse with shadows because it's overly dark color. It looks very much similar, so sometimes you might detect some shadows as solar panels, but you can use some additional attributes to remove it. Also, if you have LiDAR DM, right, because most of solar panels are on the rooftop, so that means the elevation will be relatively higher compared to the ground. So if those false positive detections are like have low resolution on the ground, you can use the polygon that we get and then do some zonal statistics to get some average elevation. Then you can filter out those polygons directly as well. So no problem. But you do need to look into the data. So there's no like perfect way of removing all the false positive detections. And is it possible to collect other features like rows and hydrologic features using this model? Not for this model, but I'll be creating other tutorials, teaching how to detect other features using other pre-trained models, or we can train our own model. Right now, it's just the beginnings because I've only been doing this for a week. So there will be a lot more to come. So stay tuned. Certainly, there will be other features, for example, detect rows, detect other hydrological features, lakes, maybe wetlands or other types. So if you're interested in learning more, stay tuned for updates on YouTube or on GitHub. Based on the solar panel area, it would be nice to calculate an estimated generation of electric energy per house. Yeah, this would be a good application. Once you have the area, and you can, depends on the solar energy, like the sunlight that you get every day, you can probably calculate the energy that has been generated. There should be some equations, and or you can use some other literature to figure out how to convert from the based on the latitude, longitude, based on location, based on the sunlight. There should be some empirical equation to estimate the energy generation. Or you can ask ChatGPT. I don't know the answer, but I guess there must be somebody has been done it because this is kind of very common applications. Next one, trying to classify buildings. I want to get all the commercial buildings, industry, halls, certain area. Where can get data set for non-residential? For large buildings, you can probably just use the open Overture maps data set. So let me quickly show you here. If you go to the GeoAI repository here and go to the documentation, in one of the examples, building footprint, no, download data. That's actually the first tutorial. You can download building data from Overture. So Overture maps produce like building data at the global scale and have really nice building footprints. So if the building has been there for a while, a couple years, most likely you already have the building footprints, and you can actually see that before you download the data. You don't have to. So pause for a second. If you need building data, don't try to do building detection on your own. There might be some OpenStreetMap data already available, or unless it's new industry area, there's no building, then you might need to do it yourself. So you can just use this sample code to download data, or you can also go to my Open Geospatial tutorial here, and I think there's a base map repository. Let me quickly show you where you can get all the buildings directly. So I'm going to type base map, and this is the URL, the repository. Let me send the link in the chat here, so you can see, you can get access to the URL. Oops, I'm not sure where's the chat, so I'm gonna put that in the chat. So this one, I have a sample script called Overture data. So you can just open this one, and then you can download this one to your computer. So just download this script to your computer. This is for using QGIS. So download this script, and then just open QGIS on your computer. Then you can just load the data. And let me quickly show you here. I'm going to open it up and then create a new project. I can load maybe some base map here. I'm going to use maybe Google satellite base map. Okay. Then you can open the Python script panel here. Okay. At the lower left corner, there should be a script. So Python script here. And from here, just click this open button. Then load the script that we just downloaded over to a data. Okay, so you should have this. Just click the run button. It should be able to load the entire global building footprint data from Overture, and then you can just use it for your area to see if there's any buildings. So don't try to develop buildings yourself before you're looking at this one, and it might take a couple seconds, but it's loading up. So take a look. This is very nice. You have all the building footprint, and some of the building actually has attributes for residential, commercial, industrial. So you can click this inspector, and then you can inspect it. It might take some time. So this is the global data set. It's like 700 gigabyte. It might be a little bit slow. So be careful. Don't freeze your computer. Okay, so this. Let me see if any other questions. Do you know if there's a pre-trained model for commercial buildings? I'm not aware of that. If you know, let me know. I'm happy to integrate into the GeoAI package. Do we need to uninstall Conda or Mamba to work with UV? No, they are independent, so you can use them side by side. I use them together. So if you need to create some quick environment, UV is much faster. If you want to create some system environment, so that so UV is more like project based. Mamba and Conda are more like system. So if you want to create an environment that you want to use multiple projects, I would prefer using Mamba or Conda. But if you want to create an environment just for a particular project because it uses different dependencies, then UV might be better. Next question, can a software developer transition to GIS? If so, could you possibly suggest a roadmap? Yeah, of course. It's like if you already have some programming background, you might need to learn like what the geospatial data format is and how to interpret geospatial data imagery. It should not take you like too much time. Once you know those, especially the coding skills, it's really easy to go from software development to do geospatial because you have strong technical skills, so you can develop your own model. But you do need to have some basic background about like what geospatial data, vector data, raster data, and how they're different from traditional data science. All right, so I think I've answered all the questions on YouTube. Let me go back to Zoom and then maybe answer last couple questions. Question about regarding open code tools introduced and what the difference among them and their specific tasks, which tool is particularly effective. Yeah, I've developed a lot of tools. I don't have time to cover all the details. GeoAI is just one of those. If you're using Google Assistant Cloud Computing, then use Gmap. If you want to use deep learning AI, use Geo AI. If you want to use interactive mapping open source in the cloud environment, use LeafMap. Actually, Geo AI built on top of LeafMap provides some additional functionalities. And there are a couple more in here. Follow the YouTube and also GitHub to learn more. And are these pre-trained models reliable for high-level research activities, PhD research? Yes, why not? But it's not going to be perfect. You are welcome to fine-tune your model. Again, stay tuned for more tutorial how to fine-tune the model. But from the the demo that I show you, right, it's pretty effective. You don't have to train your model. You can just use some pre-trained models. This is kind of like ChatGPT, right? It's giving you give some input, you only give you something, but you need to evaluate. Not all the result might be good. It depends on the particular use case, but it's pretty decent. So very low efforts, couple minutes, you get some initial result. Then you can fine tune the model. You can refine the result. It's up to you how you want to do that. There are a lot more things. Can be improved, but at least give you a good starting point to do some geospatial stuff. And last questions is not working on 3.34. I'm not quite sure because some of the API might have changed, but at least from my versions on my computer, let me check what's the version here. Yeah, I'm on 3.40.3. It works fine. It might be because different operating system, Windows, Mac, or Linux. I'm not quite sure, but feel free to open that an issue on the repository, and I will look into that. There's no guarantee because I don't know all the QGIS plugin development, but I can certainly look into that. Okay, so I think I've answered all the questions. We have 15 minutes over time, so thank you all for attending. Again, there will be the next one will be in 2 weeks because next week is the spring break here at the university, so we don't have the workshop next week, but in 2 weeks. So you'll be using the same link, also streaming on YouTube. I look forward to seeing you in 2 weeks. If you have any questions, feel free to post it on GitHub, or you are welcome to reach out to me on social media. And thank you all for your attention. I hope you find learn some useful information, although it's very basic, but you need to start from somewhere, especially if you're in the beginning to do open science, open source software development. This might help you get started. And in the next workshop, we're going to talk about open data, how you can make your data accessible on GitHub, on Hugging Face, or on other open access data repository, and how you can retrieve the data programmatically so they can feed your data into the model to do some cool stuff. All right, so that's all for this tutorial, and I'll see you in the next one. Take care, everyone. Bye-bye.